Okay, so if I want to start off first by saying if you were able to do these questions without any help, guidance, you should feel pretty proud because some of this stuff I really didn't mention in the last episode. So you kind of figured it out on your own, and that's a really good skill that you should be working on. Now, as terrible of a situation as we're all in, it's honestly a good time to try and work on your self teaching, your self motivating skills. So let me show you a couple of different versions of Half Life math. And I'm not going to do all of them. I'm going to maybe do three of them, three different ones. And then then you can try the rest of it on your own. So I'll start with number two. Number one is the exact same type of question, but number two's just got bigger numbers, so probably better if I help you with something like this. So it says all isotopes of technetium are radioactive, but they have widely varying half-lives. If an 800-gram sample of technetium-99 decays to 100 grams of technetium-99 in 639,000 years, what is the half-life? So you could look it up, right? You could look it up on table N and write it in, but that's not what the question's asking you to try and figure out to do. It's asking you to try and figure out, can you figure out how much time each half-life took? So in order to do that, the best thing to do is to kind of start with 800 and say, if I started with 800 grams, that's a G, 800 grams, how many half-lives do I have to go through to reach my 100? Not how much time, but how many individual half-lives does it take? So if I started at 800, one full half-life cycle would bring me to 400 grams. That's one half-life. Another half-life cycle would bring me to two half-lives total, would bring me to 200 grams. And a third half-life cycle would bring me to 100 grams. So what I've done here is I figured out how many half-life cycles it took to go from 800 to 100. So that's 3 half-lives. And then the math is really simple because the time of a half-life doesn't change from one to the next. The amount of time it took to go from 800 to 400 is the exact amount of time it took to go from 400 to 200 and 200 to 100. So it was 3 total cycles. Now the total time that took was this many years. 3 half-lives took that many years. So how much time is one half-life? And then it's really basic math at that point because it's 639,000 years divided by 3. And when you do that, oh geez, I wish I had a calculator. Mental math. 200 and 12, 13. 213,000 years. Got it. I think. Let me check that. Yeah, 213,000 years is the total amount. Okay. So that's the first type of question. It's giving you something. It gives you the decomposition, tells you the total time, and it asks you to figure out each individual half-life. So that's one example of something that you might be asked. If the half-life of iodine-131 is 8.1 days, how long will it take? Okay, so this is a different type. So this is one type. This is a second type. If the half-life is this, now I know what the half-life is. I know the amount of time it takes to go from 100% to 50%. How long will it take for a 50-gram sample to reach 6.25 grams? Okay, so I start with 50. Once I have my 50 grams, I turn that into 25 after one half-life. After a second half-life, the 25 turns into 12.5 grams. And after a third half-life, this turns into 6.25 grams. So again, it's 3 half-lives. 1, 2, 3. How much time did that take? Well, for those of you that like it when I go step by step, it took 8.1 days to do that. It took 8.1 days to do that. And it took 8.1 days to do that. So yes, you could have just done 8.1 times 3, but I'm showing you how I'm going to get to that actual number. So that would be 24.3 days. Okay? Okay. All right. So let's look at number 5. That's a good one, right? No, let's look at number 7. 7's a good one to look at. This is another different type. Now this one, potassium 42 has a half-life of this. How much of this 848 gram sample will be left after 62 hours? So now we have the start, and how much time, we have the start, we know how much time has elapsed, but we want to figure out how much is left at the end. So different from this question, which was telling us what we started with and ended with, and figure out the time in the middle, this question is giving us how much we started with, how much time has gone by. We want to figure out how much is left at the end. So I'm just going to keep using this arrow method because it really is the simplest. Even though the box method has everything involved in it, this one just kind of goes right to whatever you need, since we don't have to worry about fractions or anything like that. So I started with 848 grams. Okay. After 1 half-life, how much would be left? Half. So 424 grams. The time that it took is designated by this right here, 12.4 hours. So at this moment right now, we've only elapsed 12.4 hours to go from here to here. I need to know how much is left at 62 hours. So I go again, right? Plus another 12.4 hours would bring me to 24.8 total hours. Okay, so 424 divided by 2 is 212. But I'm still not at 62 hours. I'm probably going to run out of space, so we're going to start working down. What happened there? The camera does not support. What? Bear with me, childrens. Okay. Good. So I'm going to probably run out of space, so I will move along. Another half-life would be another 12.4 hours. 12.4 plus 12.4 plus 12.4. That brings my total to now 37.4 total hours. After I've completed this half-life cycle, I would be left with 106 grams of non-radioactive potassium 42. 106 grams of radioactive potassium 42. Still, not 62 hours. Continue. Another 12.4 hours. That's going to bring me to 49.8 hours. Did I do that right? Yeah. 49.8 hours. With that said, cut this in half again. 53 grams. Still not at 62 hours, so I add another 12.4 hours to reach. Oh, that's where I messed up. This was a 2, That means this was a 6. There we go. That's going to be the completion. This last half-life, 1, 2, 3, 4, 5 half-lives, is going to give me the remaining reactive potassium at 26.5 grams remaining. Okay, now, yes, for those of you that are really swift with math, you could have done 62 divided by 12.4. And if I did that, I would have found out that there are 5 half-lives. And once I know that there are 5 half-lives, I could have just done 848, 424. That's 1 half-life. 2, 3, 4, 5. So you can see. All right. What I'm trying to show you, let me get that thing out of the way. I'm trying to show you, and hopefully this helps. Although some of you don't like what I'm about to say. There are many different ways that you can do a half-life question. But if you logically understand the basis of in X amount of time, half of the sample will disappear. And then at that same X amount of time again, another half will disappear. Then you just got to play with the math that you're comfortable with. If you like to draw it out like this, that's great. If you're able to understand the math of total half-lives and go one by one, great. I suggest you do this first till you really do get comfortable with it, but I'm not really there to monitor that. So good luck. I'm going to leave you left with the last 1, 2, 3, 4, 5, 6, and try them out. The last 2 have scientific notation. Don't be scared. Just work with the numbers. Okay? Work with a calculator. Punch it in. All right? That's all I got for you this week. And I'll give you an update on Sunday, maybe Monday, about how we're going to proceed with the next quarter. So you kind of know exactly my expectations after we've moved from here into there and what I'm going to need from you in order to be successful. All right. Thank you, guys.